Hey, it's Darius. Welcome back to InventBox, where the solution is right around the corner. And in this video, as promised, we are going to start writing some JavaScript. We're going to take this sort of flow chart that I made, turn it into a working and fully functional WebGL program. So let's start fleshing this thing out. I'm going to use my favorite programming language called Scratch script or chicken scratch script. That is where I just start typing things. Like we need to go ahead and create our vertex data. And set it equal to something. And then create a buffer of some kind on the GPU somehow. And load our vertex data into that buffer. Then we'll create a shader, whatever that is. Well, it'll be a vertex shader. We'll also make a fragment shader. And then we'll create a program and attach those two shaders to the program. And then we will enable the vertex attributes that we want to use. And then we'll draw. So that is our outline in Scratch script. Let's do it in JavaScript. So our data is really going to be, the simplest thing that you could draw is a single point, but it'd be a single pixel and it would be very, very hard to see. And so we could just draw a line, but I think I'll draw a triangle. So let's go right into our coordinates, x, y, z. I'm going to start with the top of the triangle, and that will be the x coordinate of 0, because a -1 would be to the left extreme, and +1 would be the right extreme, and 0 is right in the middle. For y, I want to go all the way to the top, and for z, I don't really care because it'll be a flat triangle, and I'll just make all the z's 0. And the next, we're going to go down, where are we going to go? We're going to go to the right side of the screen, down to the bottom, and then left side of the screen, still at the bottom. And that is our triangle. Let's create this buffer thing. Just use the create buffer command. And that's it. But before we can load data into it, we have to tell GL to bind this particular buffer as the current array buffer, meaning it's an array of vertex info. Now we can run vertex buffer, we are going to run buffer data and tell it to load into the currently bound array buffer, which of course is the buffer that we just specified. Now we do need to create a float32 array out of our data. Finally, tell it what our intent is on how often we expect to rewrite the contents of this buffer. And in our case, we are not going to rewrite it after this at all. So we're going to say static draw. Now, these are, you got some options. The other main option, I guess, is dynamic draw, informing WebGL that you do intend to rewrite the contents of the buffer very often. But these are hints to the graphics card to help it optimize, make your program faster and not waste time where it doesn't need to. So we'll just go static draw. Now we need to create our shaders, and that's also pretty straightforward. So we'll start with the vertex shader. And here we specify the type, and it's a constant, vertex shader. But we're not ready to create the fragment shader yet because we still have to specify the source code for this shader. Remember that a shader is like a mini program, and it runs on the GPU, so we have to give it some code to run, right? gl.shader source. Give it the shader that you are going to be modifying. And then it's actually a string because it runs, this is the source code that runs on the GPU. It's not JavaScript. JavaScript don't run on the GPU. It's the GL shading language created by OpenGL to work with the graphics card. And that's why it's a string, because after we give it this string, we're going to tell GL to compile this guy for us. So what will this program look like? Well, it's just going to be a single function, kind of like in JavaScript, except the GL shading language is a typed language, statically typed, meaning that you have to specify the return type and the type of every variable that you define. We're not returning anything in this function, so it's void. And then we need to set a global variable called GL position, and this is the output. This is the output, here we go, of our vertex shader. And that is called GL position. It's a vector of 4 components, or an array of 4 components. And we want to output XYZ coordinates that come from the buffer according to our graphic, from buffer into vertex shader. So where does our input come from? We use the attribute keyword, tell it that is a vector of 3 components, XYZ, and we're going to name it position. So every time it runs, it will load the next set of 3 values into position, and then we can give it position, but we have to convert it into a vector of 4 components by tacking on a 1 at the end. And that's it for the vertex shader. Oh. So the vertex shader was fairly straightforward, pretty simple, and conveniently enough, the fragment shader is going to be even simpler. Now, in the last video I said that it takes the input position and transforms it into a color. Well, technically, we don't have to take any input. We can just output, we can hard code a color in there and have it just draw that, make every pixel the same color. But either way, you're going to be assigning to GL_frag color, like fragment color. And we set this equal to a vector of 4 components where it's RGBA. So red, we'll just go 1, no green, no blue, and A is 1 to make it not transparent. We'll compile that guy. Now we can create our program. And then we attach the two shaders. And finally, we use a command called link program that just ties everything together. Now that the program is linked, we need to enable our whatever vertex attributes we want to use. And by vertex attribute, I mean these extra values that we tack on, including the coordinate. So you have a vertex, and then this is an attribute, this is an attribute, this is an attribute. So we just have one attribute, and that's position. And just in case you're wondering how to tell what attributes you have, it'll be what's in your vertex shader. So first we're going to get a reference, which will be like an index number. I'll just call it position ref, or position location. I'll call it position location. And that's because it's equal to gl dot get attrib location. We specify the linked program and then the name of a defined attribute in the vertex shader. It's got to match. And it will return a number that WebGL has assigned to this attribute. It will probably be 0. It almost definitely will be 0. But for the sake of, in case you had more than one, we're going to do, you want to ask WebGL what it is. Now we can just easily run the enable vertex attribute array command. And it just wants to know the location of the attribute that we should enable. And that's just because all the attributes start out disabled by default. Next, we run another slightly more complex command called vertex attrib pointer that we used to describe to WebGL how it should load, or how it should retrieve attribute data from the currently bound buffer. The first thing is, well, which attribute are you talking about? So we'll give it the location of our position attribute. The next is, how many elements do I read at a time? So you should read 3 at a time, because XYZ. And then what type? There will be floating point numbers. And I know that because I created a float32 array. Normalized is, it's kind of an advanced optimization feature. We don't need it for this one. And stride and offset we're not using either. We will tell GL which program to use. We only have one program, but you still have to specify. That will create a executable program on the graphics card, so that whenever you say draw arrays, it will use that program to draw your arrays. We specify our draw mode according to our picture here. So if we want to take these 4 points and turn them into 2 triangles, we can specify gl.triangles. If we want to draw the points on the screen as points, it'll be gl.points. And there's a lot of drawing options. There's one called, I already said points and lines. There's also, or points, triangles, lines, line strip, line loop, triangle strip, triangle fan, and that's like a whole bunch of different options, but we're just going to do triangles because we're going to draw one triangle. Next is the starting vertex, and I want to start at the first vertex, or 0, and the next is how many vertexes should I draw all 3. I have 9 elements here, but it's one vertex has XYZ, the second vertex has XYZ, and the third vertex has XYZ. And lastly, fire up your server.js. And hope for the best. Yes, we have a triangle drawn on the screen, and that would be about 100 times easier if we had simply used the Canvas 2D rendering context, but we are not limited we're not limited to just triangles here. But that's all the time we've got for this video. So thank you for watching, and I know that I'm not going to lie, there's a lot going on here. We have made 14 different brand new function calls, and I briefly explained some of them, and you're also probably a little confused about this whole GL shading language thing and all these different steps and like all this attribute stuff, but we will get into that. But like I said, it's time to move on. So thank you for watching. See you next time.